welcome to part 18 of my Tevo Black Widow mods videos. Today we will continue where we left off in the last video. The soldering on the back panel connectors is finally done, and as you can see the wires look like a mess, but that's fine. So also there are a few close-ups, so yeah, you can see how terrible my soldering is, but anyway, that's not the point. So all that's left is to move the back panel to the control box and mount it, and then wire these to the electronics. So I've just bundled up the wires, as you can see. This is just to make it easier to route the cables while I'm mounting the back panel. So I'm just going to route these between these two red plates that the electronics mount to, and screw the back panel in. And here is the result now. So as you can see, there is quite a bit of wires for me to deal with. So yeah, let's get to that. I've now done a lot of the wiring. So what I've done is I routed a 3.3 volt cable to Raspberry Pi for the power detection. So instead of using a buck converter, which is what I was using before, I figured out it would be a better solution. But yeah, that seems to be tested. Also, I wired the bed thermistor here. I wired the hot end fan and the layer fan here, as you can see. There's also another fan marked C that's going into a uncontrolled lock fan hub instead of the other two, which are going into a PWM controlled one. And that C just runs through this buck converter, and the C stands for chassis. So it's just for these three fans on the chassis. So other than that, I've also wired the hot end heater. And what else? I've done out of the wiring on the Raspberry Pi. I wired the relay, and I've also wired the filament sensor. What else? I've wired the LED control to the relay board as well, so I will be able to test that soon, but again, that's not my priority right now, so it's not going to be in the next few videos. And yeah, I've wired all the fans to adjust as splitters here, and then wired it into this buck converter. And yeah, I think that's pretty much it. Oh, I also wired the PT100 sensor to this daughter board. So yeah, there's still a lot more to do, so yeah, I'll try to do a bit more progress and then show you the result. I'm now done with the entirety of the wiring here, so all was left was these end stops and the motors and some of the buck converters, which I'll get to in a second. But I also did add some ferrules to the end of any stripped wire that go into terminals, with the exception of this, because the ferrules that I have wouldn't fit in this, but otherwise, as you can see, I've used them for pretty much everything, and they are good for various reasons, but I don't want to make this video very long, so I'm not going to debate on that. So yeah, all the wiring is done. I ended up using only one of the 4 buck converters. Normally I needed 4 buck converters because my layer fan and the hot end fan used to be 5 volts, so I need to reduce that. And I needed one for the 3.3 volt detection voltage that comes from the power supply and goes to the Raspberry Pi to detect if the power supply is turned on or not for the power supply control plugin. And I needed one for the chassis fans. Well, turns out I now use 24 volts fans on the hot end and the layer fans, so I could just wire them into the duets directly. So 2 of them are not used because of that, and 1 of them isn't used because I'm supplying the 3.3 volt voltage from the duet directly to the Raspberry Pi. And to be able to do that, there's one modification that I still need to do, and that is on this USB cable. I need to cut the red wire inside that, otherwise the Raspberry Pi would still supply the 5 volts to this, and this would generate the 3.3 volts even though the power supply isn't turned on. So yeah, I need to do that, but otherwise the wiring there is complete as well. I've also organized all the remainder cables here as well. So as you know, I have quite a bit of unused connectors on the back side, just so I can expand on the connectivity in the future. And these are them. And here are some power wires that come from the power supply directly, and I didn't utilize these either. Some of them were meant for the MOSFET and the buck converters, and I also had a spare as well, so, and now I didn't wire the buck converters and I don't have the MOSFET anymore, so yeah, it ended up being quite a bit, but I'm not going to dismantle this entire thing just to get rid of them, so they're staying there. And yeah, I think that's pretty much it. So right now I'm assembling the hotend with the new parts, and while I'm doing so I decided that it would be a good idea to talk about why I ordered the PT100 sensor and just give you my reasoning quickly. And my reasoning is, well, it basically has two advantages. One, it's capable of measuring the temperature a bit more accurately, and in 3D printing it's not a huge deal in all honesty because the temperature fluctuates a lot, but still it should give me a bit more better temperature regulation. But the bigger reason is it is capable of reading higher temperatures, and if you combine that with a more capable heater block and nozzle, meaning this plated copper, it is capable of printing at a lot higher temperatures than the regular E3D V6, and that's not a huge deal because a lot of the materials melt at lower temperatures, and I usually don't print anything other than PLA, but still I thought it would be a nice function to have with my 3D printer, so yeah, that's the reason that I ordered it. And now the assembly is complete, so let's move on. Another thing that I wanted to discuss in this video is more of a plan for future rather than something that I'm going to be able to do in the near future, since I'm only in the research phase for this. It will take me some time to research it, then order it, which will probably take at least a month, if not month and a half to deliver. Then I need to work on it, so yeah, you won't see this in action in at least 2 months, if not more. But the thing that I'm considering doing is switching to linear rails, bearings, whatever is the correct terminology, for the x-axis and the y-axis. I'm not going to go with linear rails on the z-axis because I think these wheels are sufficient enough, and I could theoretically mount something like MGN12 rails on these slots, on these C-beams on the side extrusions, and then design a bracket from here that go over that. But yeah, I don't think that's necessary. I think it's not solid enough, doesn't wobble it too much. So I'm going to do that on the x-axis. On the other side of this, obviously, I'm going to have an MGN12 rail here and here, and the X carriage will move on that. And the Y-axis is the reason that I'm bringing this up. I'm not 100% sure on how I'm going to do that, and I'm just asking for opinions on that. If you've used any linear rails and bearings or whatever is on your 3D printer, or maybe you have a CNC background, I don't know. I've seen a lot of people use MGN12 rails on these sides of these extrusion, but my fear is that, think of this as the heat, but I don't have it nearby. Since it's only supported from the center, I feel like it will wobble too much, like this. I'm obviously exaggerating the movement. So what I feel like would be better is to design a bracket on this side and on this side, and then have linear rods like somewhere along here and somewhere along here, and use something like ceramic, I don't know, Igus bearings or whatever. And I think that will work better, but I'm not sure, so that's what I'm asking. If you have any experience with that, let me know in the comments below. On the other end, I'm done with soldering 3 of these connectors. It took me about an hour to do only 3 of these, so It's definitely taking its time, mostly because I'm terrible at soldering. You know, I damaged the board. That's just a good enough example to show you how bad I am at it. But also because this third hand is terrible as well. And I actually printed a different third hand, but I plan to make a video about this. And I actually made a video about this, I just never released it. Because it just moves around too much, and this is pretty much useless, and yeah, it came out. That's why I never released a video, so I don't recommend this. But yeah, I am getting off topic. I will try to finish these connectors by the next video. I'm not promising it, but yeah, considering that 3 connectors took me an hour, there's at least 10 more hours of work here. So yeah, we'll see that. I'll try to finish them by the next video. So other than that, I hope you enjoyed this video, and if you did, please leave me a like below, and thanks for watching.